welcome Algebra 2. We are jumping into our lessons this week, but I'm going to do something a little bit unusual. I'm actually going to work backwards for our lessons this week. So we're doing lessons 40 through 43, but in class we were covering lesson 43 and I still have some of the work on the board, so I actually wanted to talk about sine, cosine, and tangent a little bit before I erase my board. So I'm trying to be wise with the work we've already done. So we talked about what sine, cosine, and tangent are. So they are basic trig functions. Now, trig, understand that means that it can be used when we're looking at right triangles. So that's very important. So sine, cosine, and tangent are ratios that can help us solve a right triangle's angles or sides. And it's really important for you to understand that because it's not the same concept as like the Pythagorean theorem, but it's still a tool just like the Pythagorean theorem is used to find those sides. Well, sine, cosine, and tangent can also be used to find sides and angles. So let's take a look at the board, shall we? I'm going to slide this up just a little bit so you can see a little bit better. All right, so we're looking at sine, cosine, and tangent. Now, when I was in school, my teacher taught me just to say saw, ka, toa. Now, your Saxon book actually has a little fun way to remember it. Oscar had a hold on Arthur. But you have to remember, if you remember that acronym, sine, cosine, and tangent. So I just remember saw, ka, toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Notice tangent is the only one that does not use the hypotenuse. So anytime that you're looking to solve a triangle, what you're going to be doing is looking at what you have and then deciding what trig function can I use to solve for the unknown. So I like to think of it as that we always in math, we approach things with our tool belt. And we say, all right, what tool can I use? You know, a handyman, if he's fixing something and maybe there's something on the wall and he pulls out a sledgehammer, well, he's going to make a mess of it because he needs something a lot more delicate, right? So the same concept is with math. Is we have to approach it with our tool belt and say, okay, what does this need and what tools do I have available that can help me solve this? So our trig functions, sine, cosine, and tangent, are part of our tool belt that we can use to help solve those. Now, tangent is the only one that does not include the hypotenuse. Now, I used this triangle and said if I'm standing here at X, the opposite is the side that is not the hypotenuse that is diagonal from it. So A would be opposite, B would be adjacent, and the adjacent side is the non-hypotenuse side, and then C is the hypotenuse. And so I should have the little marking here to remind me that it is a right triangle there. All right, so that is how I look at it. Now, if I go ahead and write those out, the sine of X is opposite over hypotenuse, A over C. The cosine of X is the adjacent over the hypotenuse, so it would be B over C. And then the tangent, if I'm standing here at X, the tangent is A over B, opposite over adjacent. Notice that no hypotenuse is in it. Now, the neat idea is we can also do sine, cosine, and tangent of another. So if I call this angle Y and I'm standing here, then the sine of Y, now this time B is opposite. So it would be B over C. C is still the hypotenuse. So notice that both the hypotenuses are the same. Now the cosine of Y would be A is touching it, it's adjacent to it, and it's the non-hypotenuse side, and C is the hypotenuse. Now what is the tangent of Y? Well, it would be opposite B over what it's touching, A. That is not the hypotenuse. Notice that these two swapped, AB, right? But notice the c's are the same because the hypotenuse doesn't change depending on your location, right? So whether I'm standing here at x or at y, that's how my sine, cosine, and tangent work. All right, so let's take a look at some of our practice problems on lesson 43. A and B, you're simply plugging those into your calculator. Just type it in, press cosine, and you can solve those. Now, letters C, D, and E ask us to find the sine of C, the cosine of D, and the tangent of E. So if I'm looking at letter C, and let me erase this. So the first triangle looks like this. And here's my right angle. And it tells me that this is 3.61. And then I've got 6.60. And then it has the hypotenuse is 7.52. Now, it asks us, it tells us that this is C, this side right here. So it says this is C, and it says find the sine of C. So if C is here, I'm standing here at C, opposite of C. So remember, sine is opposite over hypotenuse, saw, katoa. So the sine of C would be opposite 3.61 over, and the hypotenuse would be 7.52. So that is the sine of C. Now we could do inverse sine and type that into our calculator, and it would tell us what the angle of C is. So that's very interesting. Now your book didn't tell you to find that. It just said what is the sine. So all you have to do is label it, and that's it. All right, letter D. I'm not going to draw it on the board, but it says find the cosine of D. So that would be adjacent over hypotenuse. So the side that's touching it, that's not the hypotenuse, is 3.63 over the hypotenuse 4.76. All right. So I'm going to let you do E on your own. That would be the tangent. So again, that would just be opposite over adjacent. Now letter F, find the angle whose tangent is 0.405. So one thing you can do is look at those different angles and see which one of those. Now, it may just be asking you to do inverse button of that. So if we're just looking for the angle, you just press inverse tangent 0.405 and then press equals, and it will tell you what that angle measure is. And then find the angle whose sine is. So again, inverse. On most of your graphing calculators and scientific calculators, you're going to press the second button and then press sine, and then 0.794, press equals, and it will tell you what that angle degree is. So that's your lesson 43, and we've worked a little bit backwards today. So thank you for allowing me to work backwards with you. Now, lesson 42 is about estimating scientific notation. So we're not going to take a lot of time in that. We're just going to talk about it. We've already done scientific notation where it's just one leading coefficient. I did want to point out to you that most of your scientific calculators and graphing calculators now are able to hold a lot more of the scientific notation, the longer amounts in them. So a lot of the graphing calculators, you can put the parentheses and 10 to the, and it can do all those. Now some calculators that are scientific will now write a number and then put E and then have a number. So that would be whatever this is times 10 to the 6th. So sometimes it will convert it to scientific notation for you. So when we're estimating, we know your book is teaching you there to estimate to the leading digit. So that's all that we're doing on lesson 42. Just estimate. So if I'm looking at letter A, you can do 10 times 5,000 times 5,000 times 10 times 10. So one thing that we could do there is even count up how many zeros and how many place values, and then just multiply our leading digits. So that will make it a lot easier. So scientific notation is one of those fun things, and estimating with it tells me if I'm in the ballpark. So that's important. Now, lesson 41, we did one on the board during class, And so I want to draw your attention to that when we're using unit multipliers, right? So unit multipliers is we're just setting that up so that it will cancel. So in class we talked about miles cubed, and then I had 3 different sets of my unit multipliers so that it would mark out the miles cubed. So I knew 5,280 feet are in every mile, but I had to list that 3 times since it was miles cubed. And then I still had another step to go because my final answer was in inches cubed. Now the book's not asking you to work it out, just to set it up. And that's all that you need to do there. Notice that because I had miles cubed, I had to have 3. And then to convert from feet cubed, I would need to have 3 inches cubed in order to solve those. So my friends, up on the board is letter C. So that was on page 186, and that's letter C. Let's do letter B together just to practice this concept. All right, and I'm erasing all my sine, cosine, and tangent. Woo, that was a lot of work, wasn't it, friends? All right, so letter B on my unit multipliers, it says use 2 unit multipliers to change 90 square feet, 90 feet squared, it means the same thing, right? 90 feet squared, and they want us to move it to square inches. So we're going to inches squared. All right, so 90 feet squared, and we're moving it to inches squared. Now, my term that will take me is feet to inches. So I want to make sure that I have feet in the denominator to mark out. So I'm going to say 1 foot is 12 inches. But if I only do that one time, I have feet squared. I need to do it twice. 1 foot equals 12 inches. So foot and foot make feet squared. 1, 2, 1, 2, right? So that worked out. So now all I need to do is just say 90 times 12 equals inches squared. So those are my 2 unit multipliers, and that's all that they asked us to do there in lesson 41. Now, the last lesson, which is actually the first lesson you are covering this week, is actually fractional equations, and it's solving for an unknown. So it's very important that we take the time to solve for those unknowns. What am I looking for? And to get that variable by itself. Now we did that sum in Algebra 1, and we had simple equations like y equals mx plus b, and it said solve for b. So you had to move everything else to the other side and solve it for b. Well, now in Algebra 2, we're doing the same concept, only this time it sometimes even has denominators with it. So you have to solve for that unknown. So let's take a look at letter A. So practice A, it says 5 over m minus a y equals p over x plus s. All right, and it tells us to solve for m. So if I'm solving for m, that's what I'm looking for. What I first need to do is get rid of all my denominators. So what I'm going to do is just multiply everything through by mx, and that will get rid of all my denominators. So m would cancel, and that would give me 5x minus amxy equals pm. Notice the x's would cancel, plus msx. All right, I was trying to put those in alphabetical order, right? Now it asks us to solve for m, so what I need to do is get everything that has m on one side. M, and then this also has an m. So notice all my m's. So I'm going to go ahead and add amxy, add amxy. So that leaves me with 5x equals pm plus msx plus amxy. Now, I've got all my m's on one side and everything else that doesn't have an m on the other. So what do I need to do? I need to take out the m. So if I take out the m, that would give me 5x equals m p plus sx plus AXY. So I've taken out the m. Now I'm just going to divide through by that. P plus SX plus AXY. And I've got to do that to both sides. P plus SX plus AXY. This marks out, and now I've got m by itself. Final answer, m equals 5x over P plus SX plus AXY. Woo! Friends, that was a tough one, wasn't it? Well, bottom line is you want to get rid of the denominators, multiply through, and then you just want to isolate whatever variable you're looking for, divide everything else through, so you've isolated your m. That's it. So it looks intimidating because there's a lot of variables. Just keep it organized and you'll do great. Well, that's what we'll cover this week. So that's lessons 40 through 43. And I hope you're encouraged this week, and I hope you take time to enjoy your Algebra 2. God bless you.